So good morning, everyone. We'll start with introduction about RISE. So RISE is Reboot, Invest, Scale, and Empower Yourself. So this is an initiative from Women Who Code Hyderabad to enable women on a career break to return to work. So all initiatives taken by Women Who Code is to inspire women to excel in technology and technology careers. So, which will help them to create a world where diverse women are better represented as engineers and tech leaders. And there is a code of conduct for women who code. And here everybody gets an equal opportunity to participate or volunteer irrespective of their demographic characteristics and socioeconomic status, political affiliation, or preferred programming language. And this does not tolerate any harassment of members in any form. So please adhere to the code of conduct and please read the whole code of conduct at womenwhocode.com/code of conduct. Thanks for attending the session today. So we have our trainer Kuldeep already. So Kuldeep, if you're ready, we can get started.
Yes, I'm just starting to share my screen. Let me know when you can see.
Sure.
Screen.
Yeah, we can see your screen. We can see the streams. Slide.
Okay, so good morning, everyone, and welcome again. So the agenda for the today's session is we would like to discuss about Java streams, and I hope my audio is clear, right?
Yes, it is good.
Okay, great. So we'll discuss about stream. So a little bit of a theory and kind of characteristics and the life cycle of streams quickly. And after that, we'll get into quick hands-on, like how we can create streams, different type of streams, when to use which one, and different operations available on streams, and so on and so forth. Okay, so and the streams are introduced in Java 8 only with the lambda expressions and method references, and to utilize and to see them in their full potential, we have the streams. So, and the end goal of utilizing the streams for any developer is like to be able to not to think about how to do things when writing the long operations and complicated operations on the collection without thinking and directly thinking about what to do the operations, right? Like in the SQL, we do it, right? We do not think in terms of how to achieve a particular operation. Instead, we see what we want to achieve, right? So for analogy, you can consider like all the SQL kind of operation group by, where clause, and the filter operations, and the having clause, all such kind of the corresponding operations you would be able to do in streams. And that gives a lot of flexibility, okay, without writing a lot of code. Okay, so we'll start with what are streams. So streams should not be confused with the collection framework. Streams are just the wrapper over the collections framework or the arrays. Okay, so you cannot consider the streams as another type of collections or another kind of the data storage structure. Okay, they do not store the data, they just wrap the existing, either the existing collection or existing arrays, okay, and provides you the ability to perform the chained operations, okay, like the operations which we discussed yesterday, right? Like filter operation, sync operation, the consume operation, and the transformation or mapping or change operation, right? And the other operations as well, right? So
basically stream as well as a functional interface is are for like collections. Whatever the operations are performed in the collections are performed via functional interface and stream.
Yes. So basically, you have a collection or an array, and then you convert that array or collection into a stream, and then you do operation on that stream with the help of lambda expression and method references, and then you convert that stream. Either you convert that stream back to a collection or an array, or you get a single result, like a single value, right? Yeah, like you do some operation on an average or minimum maximum operation, like that. Okay, so streams is just an intermediary state which allows you to do a lot of operations, which you the otherwise you have to do directly on collection on array, and which would have been a lot of boilerplate code for you to write if if it was not for the streams. Okay, and we'll see how much it helps. Okay, and now other thing is few points also to keep in mind when utilizing the streams, and which is very important, is that streams are immutable. Okay, once you have a created stream, okay, and once you have done an operation on it, and then once you did the operation, so you cannot modify an existing stream. You create a stream, you do you get an immutable stream. Okay, and then you do an operation on stream, and each operation produces a new stream. Okay, and at the end you get a final end result, as a side effect or a value. By side effect I mean, let's say you just print the values, so that's the side effect. And by end result I mean you store that value in some variable or some collection, so that's an end result. Okay, so at every stage in the operation which you do, you get a new stream. It is not that the existing stream is modified. Okay, and once a terminal
Is it
operation
something
is
like object?
no, it is like a string object, right? You every time you create a new string object, right? You cannot modify an existing string object. Even if you concatenate two string objects, it a third object gets created, right? You are not modifying existing string object, right?
Yeah, exactly. So stream is also something like an object.
Yeah, it is immutable. You cannot modify it. And streams are not reusable. So I'll tell you at later stage. So there are different types of operation. So once a terminal operation is done on a stream, you have to create a totally new stream, okay, from the scratch. I mean, by scratch, I mean from either the backing collection or an array. You cannot use the stream once a terminal operation has reached. Okay, and streams do not support the indexed access to their elements like in you do in the array, or you can do in list. Let's say you directly want to access the 10th or 15th element, that you cannot do in streams. In streams you have to iterate the elements from beginning till the end. Okay, and streams could be uh, endless also, right? A stream which do not have any limit, which continuously keep on producing the data based on the generator which you provided it. So that is also there. So you cannot do an indexed access on the streams. And then the most common benefit for the streams is they are easy to parallelize. So you can do the concurrent operations on them, and which gives them a lot of performance. And the stream operations are lazy when possible, which means that until and unless you invoke the final terminal operation where the end result is calculated, the in-between operations in the streams are not executed, right? So which means that the streams are executed in a lazy fashion. Okay, it is not that as soon as you apply an operation on the stream, the operation is executed. No, the operation is executed when the terminal operation reaches. We'll discuss and see that in detail at later stage. Okay, so
So
now,
streams cannot be used for integer values.
yeah, sure, they can be used for any data type which is available in our JDK. No constraint with the data types.
But it will behave like a string object.
Mm, no, it will behave like a string object, and that I told you for an example perspective in terms of immutability.
Okay,
Okay,
only
that
okay.
they can, yeah, they cannot be modified. They have to be, every time we apply operation, a new stream has to be created. But in terms of data type, there are no limitations. See, because streams are basically created from either collection or an array. A collection or an array can contain any data type, right? So
Yeah.
the stream would eventually have the same data types.
How
Okay.
about duplicate values?
Yeah, everything. If your collection has duplicate value, yeah, the stream is bound to have duplicate values. See, because I said
But
already, right?
but here
Stream do
list
not store the
set
value.
different kind of collections are there, right? Set, list.
Yeah, so that's what I'm saying. A stream is a wrapper over your existing collection or an array. So in terms of data storage, whatever is the characteristic of your collection or an array, the same is going to be reflected by the stream as well, because the
Okay.
stream is not storing data separately. It is just allowing you to do the operations on them with the help of Java 8 features, which are lambda expressions and method
So
references in functional way, right?
okay. So we have to create a list, either a list or a set, and then apply the stream. Then it works
Yes.
accordingly.
Yes, either you need to have a collection like list, set, or linked list, or hash map, like something like that, either an array. Or if you do not have, the stream has the methods which allow you to directly create the stream. You just passed on the asset of values. Okay, that is
Okay.
also, we'll see that. Okay,
Okay.
so
Got it.
uh, yeah, okay. So I just want to first have a highlight the life cycle of the stream, and then we'll directly move on to the hands-on. Okay. So the life cycle of the stream happens like this. So yeah, like this. So first we create a stream. Okay. So that is the first stage. Then we do zero or more intermediate operations. Okay, which transforms the stream to the another stream, right? So every time we do an intermediate operation, a stream is transformed to another stream. A new stream is created. Okay. So like I do the filter, I create a stream, I do the filter operation. So I create a stream, I have one stream. I do the filter operation, I have another stream. Then I do one more filter operation, I have another new stream. Okay. Then I do mapping operation, I have another stream. And then I finally do, let's say, sum operation. And at the end result, I have result, right? So the sum
So
operation at
this
the
is
end is a
a disadvantage. Is this a disadvantage?
no, it's not a disadvantage. It's how the streams are designed. We'll see. You'll not find it a disadvantage.
So the when the new stream is I mean is created, the
Mhm.
existing stream will be like will that still be linked, or it'll
Yes,
be
yes.
freed out?
So you can consider at each stage when I say a new stream is created, you can consider this as a single pipeline, and in the pipeline, the operations are added which we want to do, right? So we are continuously adding the operation that I want to do filter operation, then I want to do filter two operation, then I want to do mapping operation, and at the end I want to do some terminal operation, let's say sum operation. Okay, and when I do sum operation, all the operation which I have accumulated in the pipeline are executed. Okay.
What will happen to the when the new stream is created? What will happen to the older one?
No, the all the streams, older streams, okay, they are just acting as a operations in the pipeline. They would not be discarded till you have executed the terminal operation. And that's how I say that the streams are lazy, right? The operation is not executed as soon as you provided the operation. When you do the final terminal operation, then and then only all the operation which you previously mentioned, they get executed in the sequence which you mentioned.
So
Okay.
okay. So all the streams will still be hold in.
Yes, they will just be on hold, waiting for the terminal operation.
Okay.
Okay. So there are two kind of operations you can apply on the stream, either the intermediate operation or the terminal operation. So just for a thumb of rule, like how do you identify whether some operation is an intermediate operation or it is a terminal operation? Okay, so an intermediate operation could be identified as easily as an intermediate operation would always produce a new stream. Okay, intermediate operation always produce a new stream, and a terminal operation either produce a final value or a side effect. By side effect, I mean, let's say you return the data to file, you printed them in console, and or as a result, I mean, you collected that data, computation data in a collection array or some variable if it is a single value, right? All right. So two type of operations on the stream you have: intermediate operation and terminal operation. So the life cycle of the stream, it could be simply summarized in 3 steps. You create the stream, you do 0 or more intermediate operation, and finally you the terminal operation. That should be it. Okay. Any questions till now? And then we'll see the hands on.
No, Kuldeep, maybe if you see a practical example, then maybe we'll understand
Yeah,
very well.
yeah, sure. So we'll see first how we can create some streams. Okay, what all types of streams we can create, and maybe let's first have a glance over the stream API. So because anyway, at the end we need to look at the stream API at least. Okay. Okay, so this is your main package, JDK package, java.util.stream. And here you will find all the stream related interfaces and classes. Okay, and our main class is this one. Okay, java.util.stream inside, and there is a stream interface. Okay, so this have all the methods and the operations which you would find the documentation for them. So we'll see hands on them, but I just wanted to show you. And then we have, uh, like I mentioned the in the arts functional interfaces session also, that for every primitive type, we have separate interfaces and classes. So int stream and then long stream and then the double stream. Okay. So this stream is a generic interface, right? So which means it could be used for any data type, be it a string, your custom own classes like a user class, employee class. Okay. And but when it comes to the primitive data type, you can use this stream as well with the auto boxing and auto unboxing, right? But I'd recommend to use the specialized stream interfaces which have been designed for primitive types. Like there is an int stream for integers, there is a long stream, and there is a double stream. So all in all, you have only 4 interfaces: stream, int stream, long stream, and double stream. Okay. So for integer, long, and double, you have the specialized primitive streams. And for all the rest of the data types, you have this stream interface and you can use it. Okay. And one more thing to show, and after that we'll go on coding. This is your collection interface, which means like all the list, linked list, set, and all these have for these. This is a parent interface, and if you see, starting from Java 8, these two methods, okay, these few methods in respect to streams have been added here, right? Stream, and this is splitterator, okay? So which means to any collection, okay, whether it a list, map, or anything, okay, you can convert it to stream by calling just a stream method. All right. Okay, now let's see how we create the streams. Okay, so first we'll create a list. Okay, let's say a list of integers maybe. Okay. Or let's say instead I create a list of strings first. Okay. Okay, so that's there. Okay, so I created a simple list. Okay, I added a few values to it, and now we'll see how we can create a stream for it. Okay, so words dot, what happened? Is it? Anyways, I create a stream, and then we can do the operations, basic operations. We'll start with the basic operation, like filter operation. Okay, and now in filter, if you remember what we generally pass in filter, implementation of predicate, right? So E is the element, and what we want to do is E dot starts. Okay, you see. Okay, so what we just did is we first created a list, okay, list of few words, and then we have the list, okay, in this words variable, and on that words variable, like I mentioned, we have a stream method in the collection interface at collection interface itself. That is a top level interface for any collection, so whether it is a list, a map, or array list, or a set. Okay, so we have a stream method over the collection interface. We invoke a stream, and we get a stream. Okay, so if you want to contain this stream into a variable, okay, a stream and name the, let the stream of words variable, like we have a list in a variable, we could have that. But generally we do not do that, because a stream is, one thing is it is a immutable, and another thing is once a terminal operation is done on the stream and the stream is closed, which means we have to create another stream. So there is a no point in storing a stream into a variable until and unless we are doing a highly complicated operation, and for the purpose of readability we want to break down the chain of operations into multiple lines. Okay, so we have the stream at this
Say,
level.
no, I don't understand like what is the purpose of stream here, because yeah, without stream also the same output
Mhm.
we are gonna get.
Yes, but see, try to imagine that, see, whatever we have done, the first thing is, it is not a very complicated thing we are doing. We are just starting with the basic thing. But still, if we want to compare this as well, so see, what we did is we created the stream. Okay, so you can say this is a boilerplate thing. We did it, the extra thing, because anyway we had the list, and we on the list we can directly do the filter operation, right? Okay. But see, we had the stream, and so we directly did the filter operation. But if you have to operate on the list directly, what would you do? You would iterate over the list with the help of some for loop or iterator, right? And after that, you would do the if else, right? If it starts with, okay, let me do the corresponding without streams. Okay, so and we'll see how the code difference is there and how it impacts the readability. Okay. Okay, so how we usually do is I have for loop, and string element, I iterate over it. Okay, and then if element dot starts with h, okay, then what we do, we do print the element. All right, so you agree that we do something like this, right, to achieve the same logic, same requirement?
This is without using the lambda, right?
Yes, but okay, let me go to the uh, list interface and let's see what
But
are
like
other options.
by using lambda also, without using the stream, we will be able to do that, right? Yesterday
And
we were able to do.
yes, yes. Mm, let us explore our options because I also do not remember all of the methods, right? So
No
we
issues.
have our list and we have, so we wanted to have all the elements which contains the H letter in the beginning. So add and all clear contains, yeah, so these are all operations which returns the value. Okay, so remove all, retain all. So yeah, so how we can do is, let's say we can pass the remove all and that connection, no, that is not needed. Replace all, no. Retain all collection and no predicate. Yesterday we did this operation, right? Remove if operation. That if it satisfies this condition, then we wanted to remove it. Okay, let's see more options which allow us to do the filter operation. Okay. Okay. So one thing is remove if. Okay, that's
So
it. Okay.
inside the collection object itself, they would there will be a method for the predicate specific, the functional interface, right? Only that we will be
Yeah.
able to use.
Yes, only that we would be able to use, right?
Okay.
Because we just want to provide our logic into the predicate a lambda expression, and then that method has to accept our predicate and has to execute on that R collection, right?
So
That's
we
what
can't
we saw
use for
yesterday.
all the, all the functionalities.
We can use it, but then we have to write the whole logic ourselves. That the method also we have to write, the lambda expression we have to write. So we are kind of
So we have to
creating
create
a
the functional
framework.
interface ourselves.
Yes. So then we would end up writing a bunch of utilities and we'll them club them into a class. Okay.
Okay.
So
Okay.
what we could do is like it is not that all the time we would have the methods available which would accept the predicate and the consumer or the function or the supplier in a way we need it, right? So what we can do is usually, and that's how we do in the actual production code, that we create a bunch of utilities which accept the collection as a first parameter. Okay, so as a result, it could accept anything, list, set, map, anything, and then there is a functional interface implementation, a lambda expression as an argument as another parameter, and then it invokes that operation on the provided collection and returns the result, right? So, but
Yes.
that's another thing. Yeah. So we see here that if we wanted to do the filter operation directly on the collection without utilizing the streams, then yes, we can do it with some workaround. So it is a remove if operation, right? And our logic is that we wanted to contain all the words which starts with the letter H. Okay. So this is just a rudimentary operation. Logically, it doesn't make any sense, but for the purpose of illustration, we are doing it. So now, if we want to go with the remove if, then we need to go with the negation expression that whatever starts do not starts with the H, we remove it, right? So then we have the all the elements which starts with the H. Okay, okay, that we can do with the remove if. But now pay attention to the return type of it, right? Return type of remove if method, and what it is. It is a Boolean operation, right? So that means what I have to do is I cannot do the chaining of the operation, right? Every time I have to do something like this, right? So what we have to do is we have to do something like words dot remove if, and then our operation here, okay, some operation which we mentioned, then again, okay, then I have to do again words dot, let's say I want to do one more filter operation, okay, so again remove if, okay, then one more lambda expression here, and then I want to print it, then words dot for each, okay, and then printing logic here, okay. So you see here I'm not able to chain the operations here, okay, just dot one by one I have to type the variable name again and again, and every time I have to invoke the operation, whereas here each operation, like I mentioned, each intermediate operation, you identify the intermediate operation that way only, that it should return a new stream. So we have a stream, it returns the stream, that is a creation of stream. Then we have the filter operation, it returns the stream again. Okay, so because it returns the stream again, so we can chain the operation. So we do the for each. Okay, so like this, we can chain the operations. Okay, so see here it is a one-liner thing. We do not have to say word dot this and word dot that again and again, right? So some
Sorry,
benefit you see.
can we write the same filter operation without stream? Because I still can't find the difference between without stream and with stream, the lambda expression.
Okay, so if I have to do the same filter operation without stream, then okay, this is the filter operation which we do without stream. So it starts with the H. So if I do like this only, it would remove it. So I have to do the negation of it. Okay, it do not starts with the H, right? Okay, and now I want to print this. Okay, so words dot for each. Okay, we are just comparing that how we can do it without streams and with lambda expressions and with streams with lambda expression, right? So I'm using
Yeah.
the lambda expression for loop only. Okay.
Okay.
Okay. Okay. So let me execute it. Okay. So we did the filter operation. Now let me execute this statement. Okay, so you see, no, it still have the namaste salam. So what went wrong? Remove if. What does it return? Okay. So what is the documentation say? Removes all the element of this collection that satisfies the given predicate. Errors on runtime. Okay. And relate to console caller. True if any elements were removed. All right. So that's strange.
How so the word dot in the result, yeah, in the result screen, word dot for each that is also getting printed.
Sorry, can you come again?
In the result, actually, we are able to see that word dot for each, that statement also is getting printed. Is that so?
No, that is not printed because I'm using this JConsole, and that way I do not have to write the whole code. You see, right? I can just write the simple Java statements, and I'm able to execute them one by one, right? So,
Okay.
so that way, what it is doing is it is saying that we executed this statement, and the result of this statement is this one. Okay.
Okay.
So
Here we are
starting
performing
with this,
twice. We are
and
performing twice, right? I mean, thrice on the top without the lambda, then with the lambda, then with the stream. So all three are
yes,
getting executed.
no, only the statement which I highlight, okay, like this, that
Okay.
statement get executed. And if I do not highlight anything, then the whole code which is written in this page get executed. Okay.
Okay. Okay.
So when you are practicing or learning any API, like the stream API or like the collection API, so it gets very tedious, right? That we write the whole program and then we execute it, and then we modify that program and then we execute it again, because we have to do a lot of modification when we are learning, right? In the code, we just want to learn the functions, what they do. So better to use something like JConsole. So IntelliJ provides it, and if you do not want to install it, or if you wanted to go with the bare approach, then the JDK itself has the bundled JConsole. Okay, so you can open it like this. So it has, you need to have Java 9 or Java 9 plus. Okay, and then you can do something like this J shell. Okay, and I recommend highly, if you are practicing the stream API especially, then it would be very helpful to you. So let's say if I now do int a equal to 10, okay, and I just press enter, and then I write b equal to 20, and then I say int result equal to a plus b. Okay, so line by line, like in the JavaScript console, we do it. So line by line, we can keep on writing the Java statements, and it would keep on giving you the results. Okay.
Okay.
So let's say I do here that list dot of, and then I do something like 1, 2, 3, and then I do stream. Okay, and then I do for each. Okay. System.out.println. Okay, I mistyped it. Okay, so yeah, usually you have to write the whole class, right? Do the import and then write a class and then public static void main, right? So unnecessary your
Yeah.
time is wasted. Okay, let us go back to our example. Okay, so we wanted to filter it. Words dot remove if it not starts with the letter. If it does not starts with the H, this do not start, this do not start, but this N starts. Okay, okay. Now I see. The issue is the list dot off. When we create the list using this way, it creates an immutable list. That list cannot be modified. And that's why we are not able to remove the elements from this list. So let me create another list the usual way. Okay, that's the issue here. Mm,
So that operation, since it has happened already once, it is not taking that into account.
No, no. What happens is when you create the list using this list dot off method, okay, so
Okay.
that creates an immutable list, which means you cannot remove the elements to this created list, neither you can add the elements to this list. Okay, so if you go to documentation, you will find it. I forgot it actually. So that's why this error was happening. Okay. Okay. We go to static method, and if we see there is a off method. This we can pass different number of arguments to this, and it would create a list for us. So what it says is returns a unmodifiable list containing one element. Okay, and let's say we created 3 or 4, something like that, because there are variations of this method. Okay, over overload of this method. So see, every method is saying the same only. Returns an unmodifiable list containing 3 elements, 4 elements, and so on. So which means once this list is created, you cannot change the list through the either the add operation or remove operation. You cannot either add more elements to the list, neither you can remove the elements from the list. Okay,
Same applies
that's how it.
for the whole collection collection.
No, no, not the whole collection. Only if you create the list using this off method. Okay,
Okay.
not for the whole collection.
Yeah,
So
that's
let's
what.
say if
Suppose if I create a say array or like
yeah,
set
yeah,
something with
yeah.
off and
No, no, not with the whole of. So see, if you create the list with the help of this array list, right? Then you can do the any modification operation.
okay.
Okay. Like okay. Okay. Now it should work. Actually, with the IntelliJ JConsole, it is an issue that we have to import things manually. But if you go with the JDK supplied JConsole, you do not have to do these imports. The basic imports, the JDK JConsole takes care of it itself. But then you are left without the color coding and all these things, which helps you with the readability.
Okay.
Okay. Yeah, list is there. What's the issue? Okay, I did not execute this thing. Okay, now we see it. Now execute these statements. And yes, so see, if I execute this statement, which says only the words which starts with the letter H. Okay.
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 So
So now
here,
if you
without stream, I understand that we need to write two statements.
yes, but imagine that if we are writing a lot of operation, right? Multiple filter operations, mapping operation, then group by operations, and then at the end we are computing the result. And then you
Okay.
end up writing a lot of lines, right? Or else you could have done it in a single line with the method chaining, right?
Okay.
Just chaining the operations one by one, right?
Okay. So the filter operation with the H will be in one stream. So that stream will get created and then it will be stored. After that, when we apply for each, again a new stream will be created. You mean to say that?
No. So you see, there are two operations: intermediate operation and terminal operations, right? So
Okay.
filter is an intermediate operation, right? So like
Okay.
we discussed the life cycle of the stream, we create the stream, we apply zero or more intermediate operation, and then we apply finally a terminal operation, right?
Okay.
Okay, and just for the example, let me do one more intermediate operation. Okay, so you have better understanding. Dot map, and we get the element, and then e dot. Okay.
So which is the terminal operation here?
For each is terminal operation here.
So each and every time when we want to terminate the stream, we need to write the for each. Is that so?
No, not necessarily. So see, uh, here, let's see step by step. Okay. So this is the step, and this step involves creation of the stream. Okay. So first step in the stream life cycle. Okay. This step, filter operation, right? So the result of the filter operation would create another stream, and it is an intermediate operation. Why intermediate operation? Because every intermediate operation creates a new stream, right? So if you
Okay.
see the return type of this filter operation, can I see the documentation of it? No, it doesn't show it. And let me open the documentation from here. Okay. You see, the filter operation will return the stream. Okay.
Okay.
And like that, and every intermediate operation would return the stream. Okay. So
Okay.
that way you would be able to identify whether it is an intermediate operation or a terminal operation. Okay. And if I see the for
So
each here,
suppose if it is not returning a stream object, then it is called the terminal object.
yes. So let's say if you see the for each, then it returns the void, right?
Okay.
So that means it is a terminal operation. If you see maximum or minimum, let's say you say sum, but it is not on the, let's say I say max. Okay. Okay. So see, the max operation here gives the, okay, optional object here. Okay. This is not a stream. So it is a terminal operation. Okay.
Sorry, I didn't get your point here.
Like the for each, there is a max operation, minimum min operation, right? They also do not return the stream. So they are also terminal operation. Okay.
Okay.
So logically,
Only
how
if,
you figure out it? Yeah.
okay. In that case, I mean, when the method is returning a stream object, then it is called, then it is not a terminal operation.
Yes. Else it is a terminal operation. Okay.
So it is only for the intermediary, those methods operation, those methods will return a stream operation. So actually
Yes.
here, thing is that you are writing syntax very nicely, but if you ask me to write, maybe I will not be able to. New to me.
Yeah, but it's because we just did go through the lambda expression and method references yesterday only, right? We did not have time to practice, right?
Yeah.
Once we have a habit of writing lambda expressions, and then it's your second nature, right? You won't think about it before writing.
Yeah.
Yeah, so no issues about that. If you have difficulty understanding, I can explain. You can tell me.
Okay.
So yeah.
Very interesting to see, actually, very nice. I'm able to understand it very clearly. But if you ask me to write, maybe it'll be a little bit difficult for me because of the syntax, the methods, everything.
Okay. Yeah, I'll recommend before starting with the practice, you just go with this API stream interface, right? And
Okay.
just have a quick read. No need to memorize, just a quick read for the overall, right? Like what all methods are available, what we need to pass them, and what does they do, right? And that way, when you are writing the code, you would have idea that if I wanted to do this thing, then I have such and such method which I can utilize, right?
Okay, sure. So
Yeah.
this will be our future, implementation.
Yeah. Future implementation. I didn't get you.
I mean, whether this is being followed, this is being practiced now itself, or in future, the code will be written like this only.
No, no, no. Now itself, I mean, we are past JDK 17, so we are still at JDK 8 only.
Okay.
I mean, industry is, as far as I'm aware, industry is still at a JDK 8 because industry moves slowly, upgrades slowly. But I still hear with few of my friends and colleagues that, yeah, at some of the MNCs, we are already using JDK 11. So yeah, at least we are already, everyone is at least at JDK 8, at least JDK 8 or JDK 8 plus. So yeah, this is already being utilized and being used in the production code. It is not a new thing.
Okay.
Yeah. Okay. So we again, this filter is an intermediate operation. So the filter would return the new stream. Okay. And then we have the map. So the whatever the stream was returned by the filter, on that we are invoking the map. Okay. So and then map is again an intermediate operation. So it will this method would again return the stream, and whatever stream was being returned, on that we are invoking the for each. Okay. So because every time we are invoking a method and it is returning a stream, and the stream has all these methods, so we are able to invoke these methods without storing them into a variable, right? Okay. So then finally we invoke the for each, and we know for each do not return anything, and it is a terminal operation. And logically you would be also able to figure out, right, that we filter something, right? So after filter, there is something remaining, right, on which we can do something further, right? So that's why it is returning the stream. Again, we do the map operation. Map operation means converting something to something else. So that means the still we have the data, right, on which we can do the processing. That's why it is returning the stream. But
Okay.
logically try to see what does the for each do. For each is that we are what for each mean is that we are saying that on every element of the stream do some action, okay, and what that action is, in our case we are saying it print it. In the other scenario we could say write it to a file, right? But see, we already mentioned that on each element you do this operation, but after doing that operation we are not expecting anything that the stream is going to continue, right? I mean, the name of the each method logically or intuitive is intuitive enough to figure out that if either it is going to return any stream further or not, right? If we pay attention. So yeah, I mean, that's how I try to remember that
Okay. Yeah, I
which
understood.
operation is what. Yeah.
I understood
Okay.
clearly.
Okay. So yeah, here we have our comparison that what difference it makes from the number of lines of the code and readability and the ease of coding in terms of if we use the streams in this approach and if we use only the bare lambda expressions without the stream, and if we go with the uh, without functional approach, like writing the code from in the usual way without functional
So
style, right?
in the without using stream, I mean only the lambda. So
Mm-hmm.
will we be able to execute multiple intermediary operation like
We
after
can.
for each?
Mhm. After for each, yes, we can do, because in the collection still stays there, right? We have this list into this words one variable, right? So
So it is returning the whole
on
list only.
no, it does not return the list, right? That's why we need to use this variable again and again, right? Remove if returns a boolean variable. For each do not return anything,
Okay.
right?
Okay. 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 Okay.
That's
Okay.
why we were not able to chain the operations, right?
Okay.
Like here we did it. Like here we did not use this variable again, right? Only one time. Then
Yes.
we are working on the returned value only.
Yes. 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 Okay.
Okay. But even if you want to go with the lambda only approach without utilizing the streams, then you would hit the limitation also that all the methods which are in the streams are not available in the collection framework. Okay. Okay.
So
So
stream is yeah. Now I understood the advantage of stream. So it is advantage than the simple lambda expression.
yes, only if we are good enough with the lambda expression, and then only we have the full advantage. I mean, the whole concept and the whole working of the stream is based on the lambda expressions only, right? I mean, whatever we want to do, we supply it with the help of the lambda expressions and method references only, right? Like filter, what you want to filter, you supply it here. Mapping, how you want to do the mapping, you supply it here. For each, an action on every element, what action you want to take, you supply it here, right? So everything we are doing with the lambda and method references only, right?
Yes. Okay.
Like the actions which we want to take, we are supplying it with the help of lambdas, right? So
Yes.
without lambda expressions, working with the streams is you end up writing the anonymous classes. And once you start writing anonymous classes, then the whole benefit of this minimalistic code is lost, because it anonymous class itself is bulky thing.
Okay.
Okay.
So only with the help of lambda expression we'll be able to work with streams.
Yes. So if you look at the Stream API, you will see all the functional interfaces only, right? All the functional interfaces which were introduced with the lambdas, only those you will see. See, yeah, it is a stream only. So predicate, and
Yeah.
collector, you have not seen it. Supplier, right? Stream, predicate, function, right? It accepts all the functional interfaces. So it is meant and designed for lambda expressions only, right? All the interfaces which are mentioned here in the argument or the type parameter, formal parameters, are functional interfaces only. So they are recommending and expecting from us developers to use the lambda expressions, right?
Yeah.
Okay. So let's try to see a few more examples on how we can create the streams, and then we'll quickly move to the next steps. Okay. Okay. So we saw how we create the stream. Now let us see how we can view other streams from the stream API itself. Okay. So stream dot off. Okay. So if we want to create a stream of only one element, okay, so that we can do. So like that we can create a stream of only one element, and I'm not doing any sophisticated operation here. My intent is here for a while to just to showcase how in different ways we can create the streams. Okay. So I'll just keep on printing every stream, not do any other operation. Okay. So yeah.
After semicolon, there is a string.
Oh, okay. Thanks. Okay. And it's like that we can create empty stream as well. It would be needed at some places. So and like that, if you have multiple
But if we
elements,
create an empty stream, we will not be able to do any modification on that, right? Suppose if you want to add.
no, you cannot add elements to the stream, right? Like we
Right.
already discussed, stream is based on either existing array, existing collection, or there are methods in stream interface itself, which allows you to pass the elements at the time when you are creating the streams. Once a stream is created, you cannot add more elements to it.
So why we are creating an empty stream?
Okay, so what happens is when we are doing the mapping operation, so at those places, what happens is, let's say uh, there is a one to many mapping operation, right? Logically, you know it, one to one, one to many, right?
Yes.
So let's say you have a list of orders, right? And each order contains a list of line items, right? Let's say I order something on Amazon, right? And my order contains 3 books, right? And JavaScript, Java, and Ruby. Okay. You do another order on Amazon, right? And your order contains, let's say, 2 books, C++ and Objective-C, right? And like that, I have a list of orders. So everybody does some order, and we have a list of those orders. So every order contains list of line items, right? What we ordered, right? And now I wanted to print all the line items. So what I would do is I have a list of orders. On that, I will do the operation, and each order will go through a mapping operation, right? Which means is one order have many line items inside it, right? So one order is converted to multiple line item objects, right? But let's say some order object is empty, right? Due to something, right? You created an order and you added 2 line items into it and you deleted those line items. But your order was, now you have an empty order object, right? So now when this order object reaches the mapping operation, it has to be converted to an empty string, right? Because we cannot pass null there, right? So we'll see that, but just to tell you that such scenarios exist where we use the empty string. Okay, consider it
There
just
won't
as
be
a null.
there won't be anything on your list to order.
Yeah,
I don't understand. Okay. I didn't get it.
we'll see. We'll try to see this example, okay, and then maybe you will be able to have a better understanding. Okay. Okay, so this is another way of creating the stream, and then we have the primitive streams as well, right? So then primitive string means specifically for integer, long, and double, so that you need not to use this generic stream interface and end up having the performance overhead due to autoboxing and underboxing. So and similarly, there are long stream and double stream as well.
So you told that on the existing list only we'll be able to apply stream, but here you're writing like stream off, right?
Yes, so we have the methods available in the API that if you do not want, if you have the requirements such that you already have your elements available and you do not want to put them into the collection on an array first and then convert to stream, right? You do have the flexibility of creating the stream directly, then you do have such methods available. Or else, if you have a collection available which you are using already, then you can convert it to stream. So either you can create convert array and collection to the stream, or you can create stream by yourself by providing all the element. But you have to provide all the element at once only. You cannot do like you provide 5 elements, you create the streams and you add 2 more elements. Okay.
Okay.
Okay. So
So
here
when we create a stream like this, with the values, so
okay.
Sorry, give me a second. I'll again ask the same question.
Okay.
Okay. When we create a stream like this, what will be the collection? What kind of data type it will be? Like I see like a long stream, okay, double stream that is particularly mentioned. But whether it will behave like a list or because the sorting, the duplicate values, everything is like defined in the collection. So
Okay.
how this will behave?
Okay. So consider it like this, that you supplied a set of values and you created a stream out of it. Okay. But now, like I mentioned, that the stream is not a data structure to store the data, to store the elements, right? Stream is a API which helps you to do the operations. Okay. Stream is not meant for the storage. Streams are meant for the operations. Okay.
Yes.
Okay. So now we created the streams, multiple streams. Okay. But at the end, we'll do some computation, we'll do some operations, and we want the result, right? Okay. So when we do the terminal operation, at the terminal operation, either we could have a side effect, like we could print the values in the console or a file, or we could send it over a network call by through web service to some other application, or we want to store in a variable for the next subsequent operations. Okay. So anyway, when we are doing the terminal operation, you have to fetch those result into the different variable, and that variable is either going to be an array, a collection, or a normal data type, primitive variable. Okay.
Okay.
So the storage part would anyway come at the end, and you end up creating a variable, right? So here, let's say I just printed it, okay, as a terminal operation. But let's say instead of printing it, what I do is I do a sum operation. Okay. So obviously, if I do some operation, I need to store it somewhere. Okay. And let's say for this, I do the minimum or maximum operation, right? So let's say I do the filter operation first. Okay. And then I say that element, and let's say I filter out all the odd elements. Okay. So okay. And then I filter out all the odd elements, and then I want to what I want to do then I want to print them, okay, or maybe store them into a list. Okay. So I would say collect, and then I would say, or I can do it directly as well. See, two array I can do, okay, but if I want to store it in a list, then I would say collect, and then collectors dot to list, something like that. And then I have a list here. Okay.
So can we have duplicate values in that? I mean,
Yes,
one comma, two comma.
we yes. So if you want to concerned about the characteristic of the result and how it is going to be stored, and whether when we store it in some collection or data some other data type, whether that result is going to be compatible for it or not. So then you have to figure out the nature of operations and what elements you put it here, right? So let's say I put duplicate elements here. Okay. Let's say I put 4 again. I put 4 again, 5 and 5. Okay. So whether it's this stream would contain duplicate elements or not, yes, it would contain because I put them. If I do not put them, they would not be there. But the end question is whether when I'm storing this result into this list, okay, so I could have I would have wanted to store them in a set or a list or an array list. Okay. So then I have to figure it out that what is the nature of the data which my stream provides me. Okay. Does it have the duplicate elements? Does it have the unique elements? Okay. So that I have to figure by myself, and then I have to decide in what type of the data, what type of the data type I want to store these elements. If I want
But
to,
as per now, as per your example, you have used
Mhm.
the collection. I mean the dot collect. That method. So that will
Yes.
return a list, right?
No, no, dot collect would not return a list. Dot collect says that I want to collect the result into some data type, some collection. Okay. Which collection I mention here, collectors.toList.
Okay,
Okay.
so in the suppose
So
here if we have redundant data, then you should not store it in a list.
yeah, so then I could do something like that I want to store it in a set. Okay. That option is also available. Okay.
Okay. So based on the day, okay, now I got it. Got it.
Okay. So this collect is a reduce operation. Okay. Why we say reduce operation is it is stream is a lot of values, right? Lot of data elements. So it is reducing it to a single collection, right? It is aggregating and storing them into a collection. So the operations like collect is reduce operations. Okay. They take all the elements and put them into some container, and that container is decided by us that in what kind of container we want to put those values. Okay. Okay. And let's see if we can execute some of these values. Okay, there is an error with the line 15, but let's see with the line 12 first. Okay, so at line 10 we see that we created a name stream, we did the sum operation, and we have the sum 42 here. Okay, and then at the line number 16 we have our double stream, and for that double stream we did the for each operation, so we printed it. Okay, and at line number 14 we have some error, so let's quickly resolve that. Okay.
So because we have this duplicate,
I guess it's not because of duplicate, because the list supports the duplicate.
yeah, list suppose duplicate, yeah.
Let's figure out by printing it. Okay, so we are able to
Why
print all
can't
the
we use that
values.
collect method?
Yeah, let me just see. Okay. It expects a supplier and accumulator. Okay. Yeah, it is a 3 parameterized collector. So there is another method for that. Collect is this supplier long consumer by consumer, and this. Okay. Oh, really? Okay, no issues. It seems that it do not have the collector implemented collect method like it have in the normal stream. So we need to pass all the supplier accumulator implementations. Like here, if I see the collect method, so you see the collector is there, but there we have only one method only, which takes 3 parameters: supplier, by consumer, and then that. Okay. So then what we have to do is dot collect. So then it's to be a supplier.
So we
So
selected a different method.
yes, array list colon new. Then when we have, then we need to have an accumulator object long consumer. Okay. And it accepts the T and a long value. Okay. And now let us see.
We need to store,
See,
right?
it returned the result, returned the list. Okay. It is a list, right? Which is it is returning and then printing. Okay.
Okay. So we don't have
Okay.
to give the, we don't have to store it in a variable. I mean, the list.
Yes, we can store it, but I just printed it. Okay. In normal production code and normal when we are doing it.
Where are we actually printing? I don't know, like that print statement is not given.
No. If you do not give any print statement also, then if it is if this the result could be printed into a string format, then it would print it. Okay. I mean, it is a JConsole we are using, so it is doing it for us, so that we do not have to write unnecessary code again and again, right?
Okay. And sorry to ask, like this, the parameters in the collect, method. I don't understand what is that. What is
Yes. You are not expected to, because we have not covered till that yet. But
Oh, okay.
okay. Seriously. Okay. So it says we defined a list, says even numbers, and it contains 244. Okay. And you see it has the redundant elements, but the list do not contain those elements.
Yeah.
Okay.
Anyway, four is
So
redundant. Okay. Yeah. Got it.
yes. Okay. But yeah, so you are asking that what did we pass here? Okay. So this collect method have two kind of implementations, two variations of collect method are there. So if you go to the normal stream interface, you would see two collect method here. One accepts the collector implementation and another is a 3 parameter. Okay. So it
Yeah.
needs supplier, it needs supplier, accumulator, and a combiner. So at later stage, or I'll tell you the concept like how it works. So when we say collect, so basically this collector is there. Okay. So if you look into this collector also is containing 3 components: supplier, accumulator, and combiner. But what
Okay.
happens is we have this collectors class in Java. Okay, so that you do not have to create your supplier, accumulator, all these components yourself. So it provides an easy access to all the ready-made accumulator. So it is a factory class. Okay, so if you see averaging double, no, you leave that. So if we go the most used, like the container type, so you see toSet. Okay, so when you call this method toSet, it gives you an implementation of the collector. Okay, it gives you an implementation of type collector. Okay, and when you say toMap, then again it gives you an implementation of type collector. If you say toList, it also again gives you an implementation of collector. And if you see what collector is basically an interface. Okay, and it has three components. Okay, it has these three abstract methods: accumulator, combiner, finisher, and supplier. Okay, and all these methods you need to implement yourself. But that class, this collectors class, okay, s and the end, provides you the factory methods for most commonly used collector implementation. I mean, to collect the stream data into a list, map, set. Okay, so that is already available. So if you see, if we have a method available which accepts the collector implementation directly, we can use the collectors factory class and we provide the ready-made collectors. And if that option, but that option is not there in the primitive streams. Okay, in the primitive streams, only this three parameter method is there where we need to provide the all the components by ourselves. So how this works is, so actually it is in the end of the slide, but it doesn't matter, we can still cover it. So how this happens is, let me, okay, so it's going to take long. So I have a diagram for it that would help us understand. Partition by mono. No. Okay, I guess I do not have that diagram here. Let me do one thing. Let me see if I have it in another. So the all the code examples in the previous session as well as today are available here at this GitHub page in the repository. Okay, if you wanted to have a reference and wanted to look them at later stage, github.com/infinite trends. If you want, I can
Can I note
put
it
them
down?
in. Yeah, I'll put it in chat. Okay.
GitHub slash.
I pasted it into the chat window. Check your chat window in the Zoom. Okay, so meanwhile it is downloading. Okay, so we saw various ways of creating the streams. Okay, and we saw that there are primitive streams as well, and we saw the various ways of creating them as well. And okay, and now next we would like to see what all operations are there. So creating the streams we already covered. There are intermediate operations which are there, and then there are terminal operations which are there. Okay, so intermediate operation there are two types of operations again. There is a stateless operation and there are stateful operations. Okay, so a stateless operation, how it works is, a stateless operation do not need to remember the state or do not need to remember the elements which it processed previously. Okay, like I want to do the filter operation. Okay, and let's say I have a stream which contains 10 elements, 10 numbers, 1 to 10. Okay, so every time I do the filter operation, I just need to look at the current element, right? Like, what is this number, whether it is even or odd. Do not need to remember what number came before this number, right? So in that way it is a stateless operation. Okay, and we did the filter operation already, right? We saw how we can do a filter operation, right? We could do the definition, stateless operation.
Yes.
Okay. So like that, there are other stateless operations as well. There is a flat map, there is a map, peak. Okay, these are few of the commonly used stateless operation. So filter we already saw. Now let's see where you are check how map and flat map operation
Map
works.
also,
Okay.
I think we saw, right?
Yes.
Map also we saw.
Okay. Yes. So there are terminal operations, intermediate operations. Okay, so let's create
What
one
is stateless
example.
and stateful?
Yes, so stateful operations are like whenever we are processing the current element, we also need to remember what elements we processed previously, right? Like if I want to do the distinct operation, right? So what distinct means is that bring me all the unique elements from the stream, right? So if I wanted to bring all the unique elements, then I need to remember that what elements I've processed previously, right? Without that, how would I be able to figure out whether I'm returning the unique element, whether this element came before or not, right?
Say, from the starting, you mean to say the
Yes. So
original,
let's say,
original.
yeah. So let's say, and this stream has these elements 1, 2, 3, 4,
Okay.
4, 5, 5, right? And
Okay.
here it is doing the if I
Filter.
in the filter operation. So then in the filter operation in this code, we are not remembering or we are not storing that what element came previously. We are just concerned about the current element only, right? E is the
Yes.
current element, and on the current element we check whether it is a even or odd. That's it, right? We are not concerned about what elements came before, right?
Okay.
But let's say if I invoke the distinct operation, okay, here, okay. So
After the filter.
yes, okay. So if I invoke it, so you see after, okay, okay, okay. So it says 2, 4, and 4. Okay, but see, 4 and 4, two redundant elements are there, right? And if I do distinct here, okay, and then we see that 2 and 4 only two elements are there, no redundant elements are there, right? Now try to see if we have implemented the distinct operation by ourselves, what we need to do is we need to store what elements have came, right? So first one came, now we need to store in some collection that 1 came. Okay. Now 2 came, we store 2 in the collection. Let's say we store it in a list. Then 3 came, we store it in the list. 4 came, we store it in the list. Okay. Then again 4 came, we check. Okay, 4 is already there in the list, so we do not store it again, right? So only that's how we are able to figure out, right, whether it is a distinct element or it is a duplicate element, right?
Yes.
Yeah, so that's what I'm saying. When we need to remember what elements came before the current element, okay, then it is a stateful operation, right? We need to remember the state, previous state, right? We just
You mean
cannot
to say the
focus.
previous element alone? Okay.
Yeah, so whatever all the elements came before the current element, if we need to be aware about those elements when processing the current element, then it is a stateful operation. If we can
Okay.
process the current element without being concerned about what all elements came before, it is a stateless operation. Okay.
Oh. But this distinct
Okay.
is actually applied to the stream that came from the filter method.
Yes, you can apply it directly also without even if we remove the filter,
Yeah, yeah, yeah. Got it.
then yeah. So the other distinct operations are like the sorted, right? It will sort the stream. So obviously, if we wanted to sort the stream, we need to remember about the state of the stream, right?
So here again,
And
one more question is that, so each and every time a stream is created, the memory is actually allocated for that, right?
yes, if it is created directly without underlying collection or array, then yes, some underlying data structure is created internally. Okay. If it is
Okay.
created over the array or a collection, then no memory is allocated, only the operations are there because it did not to store the elements by itself because it is a wrapper over the collection or a array. Okay, it is
But
just
then,
applying operations on that.
okay. But suppose when intermediary operation is, being performed and it should return a stream, wherein in that case, it will store the data, right?
Yes,
I mean,
to store
somewhere
the
it,
intermediate results and do the further processing, intermediates and storage structure has to be created. But overall, no temporary structure is created for the storage.
so yeah, even because it is storing, based on the intermediary, that operation. At that time, I mean, the memory will be separately allocated for that particular stream.
Yes, yes, yes. Local variables could be created to store the intermediate states.
So each and every intermediary operation is done. I mean, a new stream will be created. So what will happen to the memory which is already, allocated for the previous one? Will it get
So
released or?
yeah, so consider it like this, like you create a function, okay? And in the function you created the local variables, right? So
Okay.
in a class there is a function, and in that function you have variables, and in class you have the data members as well, right?
Okay.
Okay. So what happens with the data members is the data member stays in the memory as long as the object is there in the memory, right?
Yes.
Okay. But what happens to the local variables of the function? How long they stay in the memory? Only till the function is being invoked. Once the function returns, the local variable goes away out of the memory, right?
Okay.
So same happens here. Those local variables are just in the scope of the memory in the calling stack of the method itself. So this distinct method is there. You invoked it. So inside this distinct method, if it needs to remember the state, it must have created the local variables in its method. So as and when this distinct method returns, those variables are gone. Okay.
Okay.
Okay, so the other stateful operations are distinct, sorted, and then there is a limit. So let's say your stream has lot of elements and you wanted to consume or you wanted to have only first 50 elements. Okay, so you can say limit and size of the limits. So your stream would have only 50 elements. Okay, and let's say you have the skip or you have the skip operation as well. So it would and skip first few elements which you mentioned from the stream and return you the rest of the stream. So let's say you have the 100 elements and you want to discard the first 10 elements, so use the skip operation. Okay, so let us try to execute and see one example for each of these operations, stateless as well as stateful. Okay, all right. So this sum is a terminal operation, for each is a terminal operation, this again for each is a terminal operation. And now let's see few mapping operation. Okay, so something which we can utilize for the map and flat map both, and which is okay. So yes, I have this example available. So what we are doing here at this line is I have this files available, word count file. Okay, so I am reading this file here with the help of files.lines. Okay, and this method, this lines method would return me a stream of string type. Okay, so now this is stream of string. Okay, and each element of this stream is a line in this file. Okay, so what this lines method do is it reads the file line by line, and every element it keeps on adding. Okay, and at the end it would create the stream. Okay, so you can basically consider at the collection level as it is a list of string, and each element in the list is a line in the file. Okay, so when we say we have stream of string, so we have a stream of lines which are from the files. Okay,
So the stream can be applied even for files.
yes. So when this lambda expressions and the streams were introduced in the Java 8, many classes were added additional methods to to accommodate the streams and lambda expressions. Okay, so like the collection class has been added with the lot of methods, the files class as well, and the maybe the socket class in the if not socket, at least the bytes channel and those classes were also being added with the methods with the lambda expression and the streams. Okay, so it has been supported throughout the JDK with the existing classes as well. Okay, so it would return as the stream of lines. Now what we wanted to do is we wanted to count how many number of the words which these files have. Okay, so to count the number of the words, we in this stream we have the lines. Okay, now we each element contains each element of this stream represents a line, and now each line would have words. Okay, so now what we are trying to do is we are want to achieve one to many mapping. Why one to many mapping? Each line have multiple words. Okay, so each line would be broken into multiple elements, and each element being a single word. Okay, so every line is been mapped to a multiple words, so it is a one to many mapping, right? Okay,
Yes.
so here what we are doing is this is a lines is a stream, so we are doing lines dot flat map. Okay, so before going with the flat map, let us go with the map first. Okay, so if we go with the map first, then what we are doing here is lines dot map. Okay, now what each line represent? Each line is a string which is representing a line in a file. Okay, and we want to see how many words are there in the each line. So we are converting each string to a number which is representing the number of the words in the file. Okay, so we have a line and we are converting into line dot we are converting it to line dot, but it is a string, right? So we need to do this split first. So we would have an array Okay, we did line dot split. So we are using a regular expression, single space, and after that we are using a plus sign. So one or more spaces, we do the split by that. So we get an array and we get the length of that array, which says us how many words are there in this line. Okay, and then after that we do the for each. Okay, uh, okay. So each line, and after that we can do the for each, which prints us the lines. Okay. Okay, so we see that the first line had 124 words, the second line had 1, the third line had 183 words, then 153. So these are the number of the words in the each line. Okay, so this is a map operation, right? Each line, so each line had a what we say, each line had a represented a line in the file, so it was a string data type, right? And we converted that string to integer, so it is a mapping operation, right? And this is how we
Number
did
of
the mapping
words or
operation.
number of letters?
No, a number of words, because we did the split by the space, right?
Okay.
So space would come after each word, right?
Okay.
So we did this split by one or more spaces. So so after that split, we have an array here, and each element in the array represents a corresponding word. Okay, and then we calculate the length of that array. Okay, so each line is replaced with the number of the words in that line. Okay, so this is how we do a map operation. Okay, that we had the line and then we converted it to number. Okay, and then we printed all those numbers. Okay, now like I mentioned that once we do a terminal operation on a stream, we need to create another stream. Con do to we cannot continue to do more operations on stream. So that I can show you here. So on the lines streams, okay. So you see lines is a stream, right? So if I do one more operation on the lines, right? I say lines, and if I say, let's say, do one more operation, which is I want to print all the elements in the line stream. So see what it says. What it says is stream has already been operated upon or closed, which means is I executed the for each operation on this lines stream already, which was a terminal operation, and which means the stream is operated and closed. Okay, now I cannot do any further operations on this stream. If I want to, then I have to create another stream. Okay, so what I would do is I would create this stream again. So I would, if I execute this line again, line number 8, then new stream is created. Okay, so you see new field, this variable again is created. And now if I do this operation without doing the operation at line number 9, then you see the whole file is printed. Okay, each line in the file is printed. So see, this was the content of the file.
Okay.
Okay. So once a terminal operation is done on the stream, if you do any further operation, it would give you an error that the stream is already closed. Okay, so now we want to see the flat map operation. So we create the stream again. And once we created the stream, now what we want to do is we want to, instead of counting how many words in the each line, we wanted to count how many words, total number of words are there in the file. So first so either we can do it in a two steps, okay, two-step process. First we count number of words in the each line, then we do the sum operation. Okay, that is also a valid approach. But if we wanted to do it directly, how we do is
We use flat map.
this, yeah, this lines is a string. We do flat map operation. So you see, each line is a string which represents a line in the file. Now what we are doing is, first we are creating an array by split operation, split by spaces. So we have an array of words. Okay, to that array of words, we are passing it to a stream.off, which means we are creating a stream over that array. Okay, so for each line we are creating a stream of words. Okay, and what this flat map operation will do is, this flat map operation would flatten that stream, which means is it would take each and every element from the stream which we created here and put them into a new stream, which is a words stream.
Okay.
Okay, and then we have a stream of words here. Over that we can do the count operation. So if I do it, sorry, so we created the word stream and we can do the count operation. So we have 701 words. Okay, and you may have noticed here we are storing the stream again and again. First we stored a stream in lines, then we stored it in words, which is not necessary. We could have done this operation in a single line here only, right? With the method chaining, it is not necessary to store it in variable.
Yes.
It is just for ease of readability. Okay, so we saw flat map operation, we saw map operation, filter operation we already saw. Okay, and okay, we have this also here available. Not this one. Yes, this has those annotations. So if you download it from there, you would also have these markings. Okay, that is another version. So I have the older version in my laptop. Yeah, so this I was talking
Can we
about. So
perform
flat,
all these in the Eclipse also?
yes, you can, but you have to write your boilerplate, right? You create the class, you write public static void main method, right?
Yeah.
You cannot do line by line, right?
Yeah.
But whatever you feel comfortable, yes, you can do in Eclipse also. So this is how our map operation works. So we have a source stream. Let's say we have a B, C, D stream of characters, and we want to convert them to their ASCII characters, right? So then there is a map operation in between, and it created each character type into an integer type, and we have a resulting stream. Okay.
The
So
method
and you
definition
see,
will be, so we need to see the documentation.
yes, documentation you have to go through once. So let's say this is a, here we have example, same example here, stream of characters A, B, C, D, E, right? So it created a stream of characters. Then we do the map operation. So in map operation, we convert each character to integer by typecasting, and then we print for each, right? System.out.println and %d, right?
So it
Okay.
prints the ASCII value.
Yes, it would print the ASCII value, because see, we in the map operation, we did the typecast of character to int, right?
Okay.
So each character is replaced with the integer in the new stream. So we have this ASCII values here in the output, right?
Okay.
Okay.
Suppose we try to print a string. I mean, convert the string. Word, not a letter.
Word we cannot typecast to string data type, we cannot cast to integer, right? Only character could be typecasted to integer, right?
Yeah.
String, if we have to count how want to convert to the ASCII value, then each character of the string has to be converted to the ASCII value, right? Then for each character, we would have an integer array representing ASCII value of each character in the string, right?
Okay. So that cannot be done.
It can be done, but you would have a then flat map operation, right? each object, each word in the string would provide you an array of integers, and that
Yes.
array of integers has to be put into a flat stream, right? Like we did it for the word count operation, right?
Yeah.
Okay. So, and then here it is your flat map example. So let's say you have an stream, and that stream has, like you mentioned, this is a word. So A, B, C, D, this is one string. E, F, G, this is another string. Okay. So this is one string only. Okay. Now, if I want to convert this string, convert this stream of strings into stream of characters, then I can do it, right? So A, B, C, D. This would be converted to an array, and then array would be, with the help of flat map, would be put into the single string, different elements, characters A, B, C, D, and E. And this E, F, G, again, this would be broken into an array, and then array would, each element of that array would be put into the resulting stream.
Okay.
Okay, and the that collect operation which we were discussing earlier. For that also I have the diagram. Yes. See, it looks a little detailed, but not that complicated if you go step by step. So we have the elements of the stream, right? And we want to put them into, let's say, list. Okay. Okay. So we had three components: supplier, combiner, accumulator. And in our case, we do not need to provide the finisher, but the finisher is also there if we want to implement the collector interface. Okay. So how it works is, the supplier would create the container which we want. So what kind of container we want to put all the elements into the list? We want to put all the elements of the list into a list, right? So list is the container for us. Okay. So your supplier needs to provide the container. Your supplier needs to provide the empty list. Okay. So your supplier provided the list 1, list 2, list 3. And this diagram is representing the parallel operation. Okay. Parallel operation on the streams. If it was a single sequential operation, then you need not to create three lists. Okay. Only one list is sufficient. Okay, but because we are working in parallel here, and let's say we have three cores available, right? Okay, so three-way processing is happening for us. Okay, so in parallel we need to have three lists. Okay, so we have three lists. So supplier creates the empty list in which we have to put the each and every element of the string. Okay, so supplier creates the container, which is a list. In our case, it created list A1, A2, and A3. Now, it is responsibility of accumulator to bring each and every element of the stream and put these into the containers list which we created. Okay, so because it is a three core operation, okay, so we would have three accumulators working parallelly, and each accumulator 1, 2, 3. So accumulator 1 would fetch an element of the stream and put into the A1. Accumulator 2 would fetch his element from the stream and put into A2 list. Element accumulator 3 would put his elements from the stream and put into A3 list. Okay, and all three accumulators will keep on doing it till the stream has exhausted. It do not have any more elements left. Okay, so let's say by the end of it we had 5 elements, and the state looks like this. That list A1 had 2 elements, A2 has 2 elements, and A3 has only 1 element because the list is exhausted now. Okay. Now we have 3 separate lists, but we wanted only one list, right? We have 3 separate lists because we wanted to do the parallel processing, so we can do it fast, right? So now we need to combine these lists, right? We need to combine this list and create a single list. So that is responsibility of combiner. Okay, so combiner will combine all these three lists, okay, and create a single list, which is A4. Okay, and A4 is the end result for us. And what does the finisher do? If we want to convert the end result, finisher A4, okay, so finisher would convert it to, let's say we want to convert this A4 list to set. So it is responsibility of finisher to convert list A4 list into set of type R. Okay, so if so this A1, A2, A3 are intermediate containers. Okay, the containers or the collections which were used in the intermediate calculation. If the container used in the intermediate collection calculation and the end result container are of same type, then you do not need the finisher. But if the intermediate containers are of different type and the end result container you want of different type, then you need to provide the finisher to provide the end result container to the different container, like this list to a set. Okay, now let me go to our example again to showcase to discuss what happened during that example. Okay, we removed that. Okay. Not this one. Not this one. Yes, we removed it. Let me see if we can get that back. Yes. So see, the first part is supplier, right? Like I mentioned. So what we need, if we want to do the parallel processing, so let's say we are doing three core processing. Okay, three cores are available to us. So we need to create three lists, right? For each of the core to work separately, independently, right? And each core would need its list to fetch from this stream and put its element to. So how that list is going to be created? So we are using the method reference here, method reference of type constructor. So we are calling the constructor array list : new. So now anyone who calls this supplier, so supplier has a get method, and inside this get method we are calling the constructor. So what we are saying is when we call supplier.get, it is going to return us the new empty list, and that logic we provided here. Okay. See, we need to create the list here, right? Green elements, right? So this is how we create the list. Now, accumulator. We have three accumulators. Each accumulator, what it does is it takes the element from the stream and put it to its corresponding list, which we created. So how does it do? So that is a consumer for us. Okay, see, supplier and then object long consumer, which means object long consumer means is it takes two parameters. One is a list and one is the element which it got from the string. Okay, so if you see, it takes two parameters. Object long consumer. No, it doesn't show it here. Do not show. Yeah, it shows the method signature. See, object long consumer, this is the interface. It has the accept method and it takes two parameters and it is a void type. Return type is void. So it takes two. One is object, another is long. Okay. In our case, it is not going to be object. Yeah, it is going to, one is object, another is long. So object is for us, it is a list, and long is the elements of the stream. So what it does is, object is a list, so it could do list dot add this long, which we got from the stream. Okay, so what we are doing, array list : add, we are doing the method reference here, or we could have done the lambda expression as well. Okay, so but it is a shorthand notation. So we are doing array list dot add, whatever list we got from the step one, on that we are doing add operation, and what is going to be added? Accumulator would fetch each and every element of the stream and it would add to this list. Now we have three lists at the end of the accumulator when all the accumulator finishes. Okay.
So
So
always there is a count like three list.
no, not always. It depends upon whether your stream is working in parallel or sequential. Okay. So if you need your stream has to work in parallel, you need to do this. Okay. Right now it is working in sequence. Okay. If you want your streams to work in parallel, you have to call the parallel method. Okay. Now your streams, whatever operations you invoke after this parallel, all would work in parallel if you have multi-core processor available in your system. Okay.
So it doesn't mean three, right? How many?
No, whatever is the number of cores available. So let's say you have an Intel quad core CPU, okay, which means 4 cores are available, and hyper-threading is available, which means each core can support 2 threads. So you have 8 threads available. So that means 8 accumulators would work in parallel. 8 accumulators would need 8 separate lists of their own. So the supplier would be called 8 times, right? And those all 8 accumulators would fetch elements from the stream and put into their corresponding list. Okay. So at the end of the accumulator space, we would have 8 lists remaining for us to combine into a single list. Okay. So how we do that? So that we do. So the last element here is combiner, and combiner, what it is by consumer. So what it takes? By consumer has a accept method. It is passed 2 objects. Okay. It is passed 2 objects, and these 2 objects for us are list. Okay, list 1 and list 2, and we need to combine it to a single list. So what we do is we do arraylist.addAll, and what it does is arraylist.addAll. AddAll method takes a collection as a parameter and adds it to the given list. So I say list 1 and list 2 were passed. So I say list 1 dot add all list 2. So I added all the element of list 2 into list 1. And like that, if we combine the 2 lists, then by calling this method by consumer again and again, we can combine all the 8 lists. Okay. So we have 3 lists and we combine them and we have a single list. Now, if we are happy with the list only, no need for the finisher, which is not needed in our case. Let's say we want to convert this list further into a set. Okay. The finisher would convert this list into a set. So what would we write into the finisher? We would write into the finisher something like that, hash set colon new. And that new constructor of the hash set would be accepting either a collection or a list. Okay. It looks very elaborate and a multi-step process when we look at the first time. But once you get used to it, you would not think of it much. You would just supply all the necessary components and you will get done with it. Okay. Any questions so far? And we are also post our time. Actually, there is a lot of topics to be covered into the streams. Not, I would say topics, but there are a lot of methods in the stream. So they cannot be covered. I mean, in 2 hours, we have a time constraint here. But yeah,
I
the
can
basic
understand.
operations we covered, like stateful operation, intermediate operations we covered. And in most intermediate operation, there are 2 types, stateless and stateful. So in that, few of the examples we covered, and then there would be terminal operations. So few of the terminal operations we already saw, like for each, sum, and minimum, maximum. So like that, there are find any and find first. These operations are also there. So
What will be the possible, interview point of questions here?
see, uh, the dilemma with the streams is that there are a lot of methods in the stream, and I don't see it a practical approach that somebody remember all these methods. You see,
Yes. Yes.
a developer do not cram the API, right? Do not do the rectification. It just have a logical concept, and then whenever it is needed, he just goes back to the API, looks it, and write the code, right? That's the general approach.
Yes.
So I expect that the interviewer is also not expecting that you remember all the methods, but
Yes.
at least you should have the idea that if I wanted to do this operation, then there is a such and such method for it, and you need to remember the basic methods, right? That you might remember the filter operation, you remember that if I wanted to do addition operation, so something like some method is there. If I wanted to do average operation, that some such kind of method exists. Or if it doesn't exist, you remember that that method exists, but I do not remember its name, and I can go on check back,
Okay.
right? So
But basically on
uh,
functional interface.
functional interface, an interviewer could basically ask like, what is a lambda expression? What is a method reference? Type of method references? That is a theoretical part. Or he could ask you to write, okay, this is a piece of code, convert into a lambda expression. And Or if he's asking, I'm going to ask you the more advanced things, like more advanced questions, like so in lambda functional interfaces, we could write default methods as well. Okay, so in default methods, there is a diamond pattern condition. So he could ask you that there is an interface A. It has the some method named let's say fun. There is an interface B. It is also having some method fun, and there is a class C which implements both interface A and B. So which method would be inherited into the class C from interface A or interface B? Because it is a diamond pattern, right? And Java do not allow diamond pattern. It is an ambiguity for the compiler. And if
Yes.
it is so, how do you resolve it? So this is a more of a well-versed question. Once you are well-versed into the Java 8 features, you can expect such kind of questions. So yeah, and like he can ask you that there is a list, and I'd ask you to sort this list using lambda expression or using streams. Okay,
Okay.
or I could ask you that I have a list, and that list has a set of elements, let's say a set of string values, and then I want you to convert each of that word into the uppercase, and then I want you to print those elements, or I want you to count the number of letters into the each word. Like so, yeah. So you may wanted to check that whether you have good hands on the Stream API, whether you can figure it out or not, right?
Okay.
But it doesn't go very in-depth interview on the stream itself, because the interview would be about Java and the other frameworks like the Spring and Spring Boot. So even if it comes to Spring, as far as my understanding, at most 2 or 3 questions, not more than that, because an interview has to see overall knowledge of the developer, not specifically about the streams, right? Streams is just one thing in the Java, and there are a lot of the other things as well, right? So not more than 2 or 3 questions, and that is also in the rare case scenario. Most of the times it is a 1 or 2 question.
Okay.
But that then again it's a difficult thing, right? Because if there are a lot of questions, we have more opportunity to answer, more opportunity to take chances, right? But if there is only going to be 1 or 2 questions, then we better answer them. So it is a
So
double-edged
we were
sword.
talking
Yeah.
about like multiple inheritance. So it can be achieved by overwriting.
No. Multiple inheritance, not multiple inheritance, because inheritance is about inheriting the functionality. But in interfaces, there is no functionality, right? There are abstract methods and default methods, right?
Yeah.
So this multiple inheritance problem arises because of this Java 8 feature, which is ability to write method body into the interface, which is default or default method, right? And that needs to be addressed via using the super keyword. So when that problem arises, so let's say you have that two, interface A and interface B, right? So you say that which method needs to come into the class C. So you say interface A dot super dot method name. You need to specify that which method needs to be inherited,
Okay.
overridden. Okay, so that you have to resolve, or else compiler will give you error that I'm confused that which method you want to override, so please better specify, right?
So with the super keyword, we can specify.
Yeah, we can mention the name of the interface and then super and the name of the method to be more specific, that which interface specifically we wanted to inherit and override.
Okay. But okay.
But more than cracking the interview, if you go with the go through the API, have a quick read over it, and do a little bit of hands-on, I don't think the interview is of much of concern, because
Okay.
at the end, interview is anyway, right? The summarization and a kind of an intro inspection of what we already know, right?
Yeah.
Yeah. It is a kind of maybe 2-3 day practice, and then that's it. Then just a regular practice, and we have it on tips.
Okay.
Yeah, so I think we are at the end of the session. So if we have any doubts which we on the topics which we covered till yet, we can discuss that. Anything?
No, no, Kuldeep.
Okay, sure. Nandini, anything for me? We are past the time.
No, Kuldeep, I think we are good. Thanks a lot, Kuldeep, for all your time.
Yeah, sure. Thank you.
Yeah. Bye, everyone.
Thank you, Nandini.